All right, let's go through the Chapter 3 problems. Number 44, after lifting off its launch pad, a rocket is found to be 480 meters directly above an observer who is 360 meters due east of the pad. What is the displacement of the rocket from the pad at that moment? So we have here is just a little bit of trig going on. We draw our right triangle. We find theta by doing inverse tangent. And then we find our resultant by using the Pythagorean theorem. So the answer is 600 meters at 53.1 degrees. 51. A Boy Scout troop marches 10 kilometers east, 5.0 kilometers south, 4.0 kilometers west, 3.0 kilometers south, 6.0 kilometers west, and 8.0 kilometers north. So here we're asked for their displacement and their distance. The displacement, it's 0 because they end up in the same place where they started. Their distance, you get 36 kilometers by adding up every part of their trip. So 8 plus 6 plus 3 plus 4 plus 5 plus 10 gives you 36. All right, let's move on then to number 54. So in 54 is saying draw the vector A 10 units long pointing due east and graphically add to it the vector B 15 units long pointing northeast at 45 degrees. Measure both the magnitude and the resultant. All right, so the magnitude of the resultant and its direction. Okay, so here's our sketch, and we've got a little bit of a dotted line extension on that scalene triangle because we want to have a right triangle. C is the hypotenuse of that right triangle. We find that its magnitude is 23 units. The angle or the direction is 27 degrees. Number 58, an athlete dashes past the starting point in a straight line run at a fairly constant speed of 5 meters per second for the first 2 seconds, and then at 10 meters per second for the next 3 seconds. At that moment, she abruptly stops, turns around, waits 1 second, runs back to the start with a constant speed in 3 seconds. So this problem is asking us to do a nice little graph of that motion, and that's what I have here. So I've got time on the x-axis, I have displacement on the y-axis, and notice that the different slopes represent her different speeds, because it does say that it's 2 seconds for the first 2 seconds it's 5 meters per second, and we see that from the rise over run of that first 2 second interval. Then we also have the slopes of the next few intervals. And we can see when she stops for a 1 second rest, that's between 5 and 6. So there's 0 slope there. And then from 6 onward, we have a negative slope because she's going backwards. All right, number 59. A cannonball fired from a gun at ground level located 20 meters away from a castle rises high into the air in a smooth arc and sails down, crashing into the wall 60 meters up from the ground. Determine the projectile's displacement. Okay, so again, we're using our trig, just making sure that we understand vectors. I know that some of you have already mastered this material, but for those who haven't, this is a good time to master it. And even for those who have, there's nothing wrong with a little bit of review to get warmed up, because we'll be using vectors so often this year. So this is your sketch, and you just set up the triangle, 20 meters, 60 meter leg. We need to find the resultant, 63 meters at 72 degrees. Number 65. A bumblebee flew 43 meters along a twisting path only to land on a flower 3.0 meters due south of the point on its hive from which it started. If the entire journey took 10 seconds, what was its average speed and average velocity? And they give you a little hint there to help you. So the average speed then is going to be the total distance traveled in this long, windy path. So 43 meters over 10 seconds, 4.3 meters per second. And then average velocity, because the displacement is only 3.0 meters, that average velocity is 0.30 meters per second south. Now notice, if you had only said 0.30 meters per second and not given me the direction, that would actually be a point off on the test. So remember, when you're asked for a vector, you always need to give magnitude and direction. 69. A driver in a cross-country race heads due east, attaining a speed of 30 kilometers per hour in 10 seconds. Maintaining that speed for another 30.0 minutes, he then makes a hard 90-degree left turn and heads north. After 50.0 minutes at that speed and heading, he veers right and slows, moving northeast at 20 kilometers per hour for the next 40.0 minutes, at which point he crosses the finish line. Oh, sorry, I was just reading the wrong problem. My bad. 69. Determine the two acute angles of an exactly 5, 12, 13 right triangle accurate to 2 decimal places for significant figures. Okay, so we've got our 5, 12, 13 diagrammed here. We've got our angle alpha, which is just inverse tangent of 12 over 5, and our angle beta, which is inverse tangent of 5 over 12. All right, 71. A telescope pointed directly at the top of a distant flagpole makes an angle of 25 degrees with the ground. If the scope is low to the ground and 25 meters from the base of the pole, how tall is the pole? Draw a diagram. All right, so you probably did plenty of stuff like this in math, so that's a pretty easy problem. You just get h by finding the tangent of 25 and solving for h. And so h is 12 meters. All right, 72. A Roman catapult fires a boulder with a launch speed of 20 meters per second at an angle of 60 degrees with the ground. What are the projectile's initial horizontal and vertical speeds? Draw a diagram. So this is very similar to the last one. The thing that sometimes physics students have to get used to, though, is that velocity and acceleration are vectors that are represented by lines, okay? But just because it's represented by a line, that doesn't mean that there's an actual distance involved, even though lines have lengths. So lengths represent magnitudes, but that doesn't mean that a speed vector has length, because speed is, distance divided by time. So what we do when we do trig on 72 is we get the horizontal speed, and that's going to be 20 cosine 60. That's going to be the adjacent leg. And then the vertical speed, which is the opposite leg, we get that by 20 sine 60, and that's 17 meters per second. 75, or 74. A pintail duck is flying northwest at 10 meters per second. A, at what rate is it progressing north? B, what is the magnitude of its westward velocity component? Draw a diagram. And so we have pretty much the same thing in 72. I know I'm flying through these problems because this is a pretty easy problem set. There's not a lot of physics to explain. I won't normally be going so fast through problems. I think most of you are probably just fast forwarding through parts of this video because you just need to get the answers. And that's perfectly fine. Use these videos as you need them. You can skip entire parts. That's fine. All right, and so in 74, we find that because it's a 45-degree angle, components are equal. They're equal and perpendicular, and we have 7.1 meters per second for both the north and the west components of this velocity. 75. A bullet is fired from a 1910 9mm Luger pointed up at 32.0 degrees with respect to the horizontal. If the muzzle speed, that is, the speed at which the projectile leaves the gun, is 300 meters per second, find the magnitudes of A, B, and C. All right, so if we want to find the horizontal velocity, we do 300 cosine 32.0 degrees, and we get 254 meters per second. The vertical velocity is 300 sine 32.0 degrees, which is 159 meters per second. And of course, C, we don't really need to do because, by now we understand where the trig comes from. All right, number 81. This problem will help us better understand the notion of velocity. Just as it comes out of a cannon, a projectile has a vertical speed of 200 meters per second and a horizontal speed of 100 meters per second. A, what is the relationship between the magnitudes of any two perpendicular vector components and the magnitude of the resultant? B, at what speed did the projectile leave the gun? All right, so really 81A is just, again, a trig review. So you should be able to write R equals square root 100 squared plus 200 squared. If you said it in words, that's also fine. And B is 224 meters per second. 85, this is our last problem. A chicken is resting at a location 3.0 meters north of a stationary farmer who weighs 185 pounds. The chicken then meanders to a new location 3.0 meters east of the farmer in a time of 2.0 seconds. Compute the bird's average velocity during its little journey. Now you're probably asking yourselves, what do I do with the 185 pounds? And the answer is nothing. It's just superfluous information that was thrown in there to trick you. I don't know why they did that. Anyway, if you sketch the path, we can see that it's kind of a roundabout way of making that trip. But what matters is the difference between starting location and ending location. Because it says that it meanders to a new location 3.0 east of the farmer. Now, it starts north and ends up east. That's how we knew to draw it like this. And what looks like the origin there, or if you like, what looks like the 90-degree angle of this right triangle, that's the farmer. All right, so then we just use our regular triangles. You know how we have common triangles, 45, 45, 90, 30, 60, 90, 3, 4, 5. Well, we know this is 40, 40, this is 45, 45, 90. Therefore, the hypotenuse is always root 2 of the leg. And so it's 3.0 root 2 meters. The average velocity then is going to be displacement divided by time. So 3.0 root 2 meters divided by 2.0 seconds gives us 2.1 meters per second southeast. All right, hope those solutions helped. I will see you in class.